Thank you, Chairman. My name is Yoshiki Demoto. I'm a second year student of the master course from the University of Tokyo. Today, I would like to present about our study. The title is Monte Carlo Simulation to Predict Fracture Initiation in Mild Steel. This is the agenda of today's presentation. First, I introduce my study, and we propose the formulation of the fracture initiation process. Then, the model to predict fracture initiation is developed, and validated the model by comparing with experiments. Then, last conclusions. First, introduction. Our study deals with cleavage fracture initiation. Cleavage fracture initiates from small flow abruptly and unstably propagates once it initiates. In constructions, it leads serious accidents, so to prevent cleavage fracture initiation is very important. The resistance to cleavage fracture is called toughness. Toughness is affected by microstructures because cleavage fracture has the weakest link mechanism, which is the phenomenon depending on the weakest part of material support structures. So to understand cleavage fracture initiation, the quantitative relationship between fracture toughness and microstructures needs to be clear. Up to now, there are many studies deal with cleavage fracture initiation, deal with the relationship between toughness and microstructures. Most of them show empirical estimation, but not to predict the relationship. Shibanuma et al. Proposed the numerical model to predict fracture toughness for ferrite cementite steel. However, ferrite cementite steel is not the material used in practice. So the prediction of cleavage fracture initiation for practical steel has not been accomplished. Now, the objective of this study is the development of simulation model to predict cleavage fracture initiation in mild steel. Mild steel is the most popular steel for practical use, and it has dual phase structures, ferrite and pyrite phases. Next, I explain about formulation of the fracture initiation process. In this study, the microscopic mechanism of cleavage fracture initiation is assumed to be divided into three stages: nucleation of crack at pyrite particle, propagation into ferrite matrix, propagation across ferrite grain boundary. The macroscopic cleavage fracture is assumed to initiate after stage 3. From now, I'll explain the critical fracture condition at each stage. First, stage 1, nucleation of crack at the pyrite particle. The state of crack initiation is formulated by using probability. The crack initiation probability is formulated by equivalent plastic strain, like this formula. Next, stage 2, propagation into ferrite matrix. The local fracture stress of the Griffith theory is used as critical condition of stage 2. The shape of a microcrack is assumed as ellipse based on 3D measurement. The local fracture stress of the proposed model is lower than a conventional model. Next, stage 3, propagation across ferrite grain boundary. The local fracture stress of Griffith theory is also used as critical condition of stage 3. The shape of crack surface is assumed as circle in this stage. Effective surface energy is assumed to depend on temperature based on previous study. Then I'll explain development of the model to predict fracture initiation. In developing the model, at first the database is constructed. The area where the crack initiation sites can be is defined as active zone. The active zone is divided into volume elements which are the same size cubes. Then, Ferrite grains and Ferrite particles are assigned into volume elements by random sampling. On the other hand, finite element analysis is conducted based on the test condition. As a result, the database of microstructures and the local stress and strain in each volume element are constructed. I explain assignment of crystal grains in more detail. The Monte Carlo method is used to assign crystal grains. The number ratio of Ferrite particles are calculated at each volume element as the threshold to define which grain should be assigned. The size of assigned grain is determined by random sampling based on the grain size distributions. And the assigned grain is put into volume element with crystal orientation. Repeat this procedure until filling of a volume element. The fracture conditions are evaluated at each volume element based on the database made in the above modeling part. When all the fracture conditions are simultaneously satisfied at any volume element, it is assumed that cleavage fracture initiates. This is the assumption of the weakest link mechanism. Next, validation of the model. We conducted fracture toughness tests to validate the model. The five types of steel are used to validate a model. These are micrographs of test steels. Test steels have different carbon contents and different grain size distributions. 3-point bending tests are conducted as fracture toughness tests. We use 5 types of steel and 4 to 5 temperature conditions at each type of steel. The critical accuracy CTOD is adopted as toughness index value, which can be calculated from this formula. The distance from the notch root to the fracture initiation site is also adopted as toughness index value. It is identified by tracing river pattern markings on the fracture surface. These are setting conditions of the model to predict fracture toughness tests. Calculations are conducted 10 times at each test condition. And this is the comparison of experiments and predictions. At first, fracture toughness, critical accuracy, CTOD. We can see that good agreements with experimental results and predicted results. And almost all the experimental results are within the scatter of prediction. Then, next, fracture initiation sites. We can also see good agreements with experimental results and almost all the experimental results within the scatter of prediction. And conclusions. We developed the simulation model using Monte Carlo method to predict cleavage fracture initiation for mild steel. The microscopic process of cleavage fracture initiation into three stages is divided into three stages and formulated based on the experiments and observations. The 3D microstructures is modeled by Monte Carlo method to be applicable to the microscopic fracture process. The model is validated by comparing the fracture toughness and fracture initiation site in 5 types of steel. In short, we developed the simulation model to predict fracture initiation in mild steel. And we validated the model by comparing experiments in various types of steel. It's all. Thank you for your kind attention.